Hello there. So let's talk about integration. So under this topic, we're going to look at the basic principles of integration, and then from there, we're going to look at indefinite integrals, and then definite integrals, methods of integration, where we're going to look at substitution, integration by parts, partial fractions, and reduction formula method. But in this video, let's discuss about the basic principles of integration. So there are about 10 basic principles of integrations that you must know in order to solve questions under integration. So the first principle says, if you have a variable x raised to the power n, then its general antiderivative will be that power plus 1, then divide that variable with the sum of the power plus 1, then add the c to that function. So remember, n must not be equals to -1. Then from there, the second principle says, if you have a function, a sine function with a constant, then its antiderivative would be -1 divided by k, by that constant, cos kx plus c. For we know that the antiderivative of a sine function is simply negative of cos function. That's where that negative is coming from. And remember, each and every time you evaluate integrals, add a c to each and every function you are evaluating. The third principle is similar to the second principle. Here it is the cos function. So for a cos function, its antiderivative is sine. So if you have a constant, then just say 1 over that constant, then you get the antiderivative of cos, and then plus c. So the trigonometric function antiderivatives are all similar. If you see here, what you should just know is the antiderivative of each and every trigonometric function, otherwise the system is simply the same. In a case where you have a constant, just to say 1 over that constant and get the antiderivative of that function there. So the pattern is simply the same. So let's have an example. We see how we can apply these principles in some problems. So we have an example here which says, find the general antiderivative of each of the following. A, the function f of x equals to x raised to the power 6, and then b, hx equals to sine 2x. And then lastly, we have the integral of sine 2x minus cos x squared of x. So let's start with a, which is fx equals to x squared. So for a, we are going to use the first principle. The first principle here, since the first function, this function here, is simply x to the power 6. So the first principle says, if we have x raised to the power n, or a variable raised to the power, then we simply add 1 to that power and divide the sum of that power plus 1, and then we simply add c to that power. So to do that, fx equals to x to the power 6 would be just we add 1 to that power, and then we divide that function with 6 plus 1 again. So here we have 6 plus 1, and then divide by 6 plus 1. So that would be x to the power 7 divided by 7. So that is the antiderivative of the f of x equals to x raised to the power 6. So for the second one, they're saying find the antiderivative of h of x equals to sine 2x. So for this one, we are going to use the second principle of the sine function, and then here we also have the constant, which is 2. So what we are going to do, we are going to get 1 divided by that constant we have, and then you get the antiderivative of sine, which is cos, negative cos, and then you add c. So remember, to this question as well, you add a c. So for this one, which is hx equals to sine 2x, what we are going to do is that this 2 is a constant. We are going to divide 1 by that constant 2, and then get the antiderivative of sine, which is negative cos, and then 2x. That is the second principle, which is this one here. It says the constant, divide 1 by that, the constant there, and then from there I get the antiderivative of sine, which is negative of cos, and then kx the way it is, and add c to that function. So to this function we are going to add a c. Okay, so this is the antiderivative of that function there. Then for the last one, which is the integral of sine 2x minus cos x squared x dx, this one we are going to use the second principle, which is the principle of the sine function with a constant, and then together with the fourth principle, which is the fifth principle, which is the cosec squared function. So remember, the antiderivative of cosec squared is simply negative cotangent. Okay, so to apply that in this question, what we are going to do is that we are going to say the constant, which is 2, we're going to say 1 divided by that constant 2, and then from there the antiderivative of sine is negative cos 2x the way it is. And then from there, for the antiderivative of cosec squared is simply negative cot. So it will be, here we don't have a constant, so we're not going to divide 1 with anything here. Simply 1 over 1, it will be just 1. So we are going to get it the way it is, which is negative cot x. That is the antiderivative of cosec on the fifth principle here. Cosec squared is simply cot. And then from there we are going to add a c to our function. So when you multiply here, which is negative by negative, we are going to have a positive here. So this cot x will be a positive, and then from there this one here, which is half multiplied by cos 2x, will be just negative. Since we have a negative there, it will be just a minus cos 2x over 2 there. And then don't forget to add a c each and every time you evaluate an integral. So this is the solution to that question there. Okay, so thank you very much for watching. Remember, don't forget to like, subscribe, and leave out your comment in the comment section below.